Let's go to page 256. This is lesson 4.6. This lesson is to use congruent triangles. So let's go and read through the paragraph. It says, by definition, congruent triangles have congruent corresponding parts. So if you can prove that two triangles are congruent, you know that the corresponding parts must be congruent as well. So this section, the key lesson is right over here. Okay, corresponding parts of a congruent triangles are congruent. So again, corresponding parts of the congruent triangles are congruent. So if two triangles are congruent, then their corresponding parts or the matching parts are congruent to each other. Now, in the reason, you don't have to write out the whole sentence. You can use the abbreviation. Okay, so you write down CP.256-258. Okay, so the abbreviation for this is corresponding part of congruent triangles are congruent. Okay, so there could be a reason. So you don't have to write out the whole sentence. Just write down CP.256-258. Okay, so that's kind of the key concept for this lesson. Okay, so let's go over example 1. So page 256, example 1. Okay, so you have the giving. I'm just going to use a black pencil. So the giving is angle 1 is congruent to angle 2, and angle RTQ is congruent to angle RTS. And you want to prove QT is congruent to ST. Okay, so you have the two triangles right over here. Okay, so this is R, T, Q, and angle 1, angle 2, S. Okay, so first, so here's your statement. And here's your reason. Okay, again, step 1, we always write down the giving. So angle 1 is congruent to angle 2. So as you write down, you need to mark on this. So angle 1 is congruent to angle 2. And notice I use the arc and also a hash. Okay, I just kind of out of habit of doing that. Okay, you can just go and use an arc if you want to. Okay, and so again, there's no certain rule say you have to do a certain way. As long as you can make things obvious, they are congruent. Okay? And angle RTQ is congruent to angle RTS. So RTQ, so that's this one here. I kind of like to do it this way. I like to use one arc and two hash, okay? Because I'm more used to the hash marks. So some people use one arc and two arcs, but I like to use an arc with one hash, arc with two hash. Okay, so you can do any way you want as long as it's obvious when people look at it, know what you're doing. Okay, and the reason would be giving. Okay, now remember when the two triangles to be congruent, you need to get 3 parts, right? So now you got 2, right? Okay, so when you run out of stuff, then what you do is you use the reflexive. Okay. So step 2, you want to say RT. Again, when you have two triangles butt against each other, you always look for reflexive. If it's corner to corner, you're looking for vertical angles. And so this would be reflexive. And you can just use abbreviation. You don't want to write out the whole thing. Okay, and so this would be like this. Okay? And now we can say the triangle. Again, when you write down the triangle, right? one of the easy way to do it, just follow what is already given like that. So you can go R, T, Q, because you know that these letters already match correctly. So if you just use those letters, but instead of angle, use triangle, okay, and then you would be safe. Okay, and the reason would be, this would be what? AAS, right? Okay. Now, the next part is now you can using the CP/CTC. Now you got two triangles that are congruent, means all the corresponding part will be congruent. So now you can say that QT is congruent to ST. Okay, you can say that the things that you want to prove. Okay, so QT would be this right over here would be congruent to that. Okay, and the reason would be CP/CTC. Okay, corresponding part of congruent triangles are congruent. Okay, so that's how you do the proof. Again, you use what's given. They usually give you two information that you can get two congruent parts. Then you have to look for the third one. Okay, and so here's kind of you have to use experience to figure out where to look for the third one. When two triangles are butt against each other like that, you use a reflexive. Okay, if the triangles are like corner to corner like this, okay, if it's like this kind of situation, you use vertical angles. Okay. And if it's like a parallel lines like this, okay, you look for alternate angles, or sometimes they use corresponding angles. Okay, depends on how the picture show up. Okay, so you have to know those things to look for the third things. So once you get the three congruence, then you can use one of those reason on the handout from the previous lesson, and after that you can go on from there to to prove the congruence of other parts. Okay. Okay, now let's go to page 257, example 2. Okay, so these are the real-life application of using the geometry. Okay, so surveying is a user-defined method to find the distance across a river, okay, from the point N to point P. Okay, so this is where the geometry and trigonometry become very useful. You can measure things that you cannot do it directly because you cannot just get a measuring tape and measure the distance, right? So how do the engineers figure out the distance between the width of the river? Well, they use geometry and trigonometry. Okay, so over here this is how they do it. Okay, so this is one of the way they do it, but because with the technology, with the laser surveying, it can become much more accurate and easier. Okay. Because with trigonometry, all you need is one triangle. Again, you're going to learn more about that in the future. Okay, so it says place a stake at K. So put a stake over here on the near side, so that NK, okay, is perpendicular to NP. Okay, so what you do is you kind of from here, right? You kind of go straight so that it's a right angle, okay, and stick right over here. Then next you find a midpoint because this is on the shore, so you can measure the distance, right? So basically you put a stick right over here, and you kind of put a stick over here so that it forms a right angle over here. Okay, and then from here you'll find a midpoint. Okay, and so from here, right? So then you have to locate L so that NK is perpendicular to KL. So again, from here once you get this line, you draw a perpendicular line. Okay, so a perpendicular line, and you line up the point so that you can kind of like stand over here, and you keep walking, and look at that stake, see if you line with P. So you walk a little bit more and see if you line up with the P, M and the P. Keep walking until you get the point L. Then you can see that the M and the P lines up. Okay, that means they form a straight line. Okay, so again, remember the collinear. Collinear means when 3 points are on a straight line, right? So when you can line up, so when you stand over here and you look that M and the P are lined up, then that's how you know you have a straight line. Because if you're right over here, if you're standing over here, let's say if you're standing right over here, and you look at the stake on the P, on the M, notice you miss the P, right? So you walk a little bit more. So you keep walking, okay? So you walk, let's say you walk over here and you take a look again, see? You don't see the stake over here. So you keep walking until you reach L and you look at, when you walk to the point L and you look at the M and you can see the point P. They all line up, okay? So you look through the scope and you can see the point M and the P line up. Then that's how you know that you found the correct point to form two congruent triangles, okay? So once you do that, then you can find a distance because this triangle will be congruent, right? Because remember, this is congruent to that because the midpoint, right? This is the midpoint, so this will be congruent. And this will be vertical angle, okay? Because the vertical angles are congruent. So you have LA, right? Because these are right triangles, so LA. So therefore, these two triangles are congruent. And once these two triangles are congruent, then CP, this and this will be congruent. So all you have to do is measure this distance, then that's how you know the distance of NP, okay? So that's how you do, real life applications. Okay, so let's go to example 3. Okay. Okay, so let's go to page 257, example 3. Okay, so again, first you write down the given. Angle 1 is congruent to angle 2, angle 3, congruent to angle 4. Like I said, they always give you at least 2 informations, and you have to come up with a third one. Okay, so again, this is how you get ready for the proof. Okay, so first, okay, so again, let's go and write down information. So angle 1 is congruent to angle 2. So when we do that, again, as soon as you write it down, this is angle 1, this is angle 2, 3, 4. Okay, so angle 1 is congruent to angle 2. Okay, so mark that. And then it also has angle 3 is congruent to angle 4. Okay. Okay, now remember what I said about they always give you 2 and you're looking for the third one, right? So the third one you're looking for, since you're talking about this triangle, the third looking for is this right in between here. Okay, see over here? So 2 triangles are butt against each other. Okay. So step 2, I'm going to say that CA is congruent to, okay, so C is, okay, so it is congruent to CA. Okay, so that means this is congruent to itself, and this would be reflexive. Okay, so now you have the triangle is congruent to bottom triangle. Okay, so step 3. Okay. And the best thing to do is, okay, let's go triangle CDA is congruent to triangle CBA, okay? And this would be ASA, okay? Okay, now once I get this triangle congruent, now I need to get to BCE, okay? I need to get to the small triangle right over here. I need to get to this triangle. Okay, that's what I'm looking for. So because of that, I can use my CPCTC. Okay. So I can say number 4, I can have CD is congruent to CB. Okay. And this would be CPCTC. Okay. The next thing is I can say that CE is congruent to CE. Okay, because remember when you have two chunks apart against each other, you're looking for reflexive, right? Okay, but this also can CPCTC also. Okay, you can say that it is reflexive or CPCTC, either one. Okay. Okay, so you can either use reflexive, or actually, yeah, you cannot use CPCTC because you don't have a triangle yet. You have to use reflexive. Sorry about that. Okay. So now you can see that these triangles are congruent, right? So now you can see the triangle BCE is congruent to triangle DCE. And from the marking, you can see it's going to be SAS, right? Okay, so SAS. And after that, then that's done, right? Okay? So again, that's how you do the proofs, okay? And on the next page, this over here, doing constructions. So you can kind of look it over yourself. We're not going to not focusing on the constructions, okay? But basically, you can you can kind of look it over the reason, okay? But instead of the difference is instead of you draw it with a ruler, you draw it with a compass. Okay, that's kind of the difference between the regular proof and the construction.